Welcome to Learn Python for Beginners, a full course generated entirely by artificial intelligence. In the next 10 minutes, you will go from knowing absolutely nothing about Python to writing your first real programs. So what is Python? Python is a high-level programming language created by Guido van Rossum back in 1991. It is used by some of the biggest companies in the world. Google, Netflix, NASA, and Instagram all rely on Python. What makes it perfect for beginners is that it reads almost like plain English. And right now, Python is the most in-demand language for artificial intelligence, data science, and web development. Let's get started. Before we write any code, we need to install Python. Head to python.org and download the latest version of Python 3. On Windows, run the installer and make sure you tick the box that says Add Python to Path. This is important. On a Mac, you can use the official installer, or if you have Homebrew installed, just run brew install Python 3 in your terminal. Once installed, open your terminal or command prompt and type Python 3-- version to confirm it is working. You should see a version number appear. For writing code, I recommend Visual Studio Code. It is free, lightweight, and has an excellent Python extension. Now let's write your very first Python program. Create a new file called hello.py and type these lines. The print function is how Python displays text on the screen. Notice we don't need semicolons, curly braces, or any complicated syntax, just write print, followed by your text inside quotes and parentheses. Lines that start with a hash symbol are comments. Python ignores them, they are just notes for you to read. Save the file, open your terminal, navigate to the folder where you saved it, and run Python 3 hello.py. You should see the text printed out. Congratulations, you just wrote and ran your first Python program. Variables are how we store information in Python. Think of a variable as a label box. You give it a name and put a value inside. In Python, you don't need to declare the type of variable. Python figures it out automatically. A string holds text and goes inside quotes. An integer is a whole number. A float is a decimal number. And a boolean is simply true or false. Notice they are capitalized in Python. You can use the type function to check what kind of data is inside a variable. Python's ability to automatically detect types is called dynamic typing, and it makes the language much faster to write. Strings are one of the most used data types in Python. You can join strings together using the plus sign. This is called concatenation. But the modern and cleanest way to include variables inside strings is using f-strings. Just put an f before your opening quote, then wrap any variable inside curly braces. Python has dozens of built-in string methods. Upper converts to uppercase. Strip removes any whitespace from the beginning and end of a string, very useful when processing user input. And len gives you the length of any string, telling you how many characters it contains. Python handles maths just like a calculator. Addition uses plus, subtraction uses minus, and multiplication uses an asterisk. Regular division always returns a decimal, even if the result is a whole number. Floor division, using 2 forward slashes, rounds down to the nearest whole number. The modulo operator, the percent sign, gives you the remainder after division. This is surprisingly useful in programming. Double asterisk means to the power of. Python also has a built-in math module with more advanced functions like square root. Just type import math at the top of your file to use it. If statements allow your program to make decisions. The syntax is simple. Write if, followed by a condition, followed by a colon. Then indent the code underneath. Python uses indentation instead of curly braces to group code together. This is very important. Python is strict about indentation. If the first condition is false, elif, which stands for else if, checks the next condition. And else is the fallback that runs when none of the conditions are true. You can compare values using double equals for equality, not equals, greater than, less than, and so on. These return either true or false. Loops let you repeat code without writing it over and over again. The for loop is the most common. Range of 5 generates the numbers 0 to 4. Python always starts counting from 0, which can feel strange at first, but you will get used to it. You can also loop directly through a list. Python will go through each item one by one. The while loop keeps running as long as a condition remains true. Be careful with while loops. If the condition never becomes false, your program will run forever. The count plus equals 1 line increases count by 1 each time, which eventually makes the condition false and stops the loop. A list is a collection of items stored in a single variable. You create a list using square brackets, with items separated by commas. You access individual items using their index. Remember, Python starts at 0, so the first item is at index 0, the second at index 1, and so on. A negative index counts from the end, so -1 gives you the last item. Lists come with useful built-in methods. Append adds an item to the end. Remove deletes a specific item. Insert lets you add an item at a specific position. Len gives you the count of items, and sorted returns a new alphabetically sorted version. Dictionaries store data as key-value pairs. Think of it like a real dictionary where you look up a word and get its definition. You create a dictionary with curly braces, and each entry is a key followed by a colon and its value. To access a value, use the key name inside square brackets, like person of name gives you Alice. You can add new keys simply by assigning to them. And you can update an existing key the same way. To loop through a dictionary, use the .items method, which gives you both the key and the value in each iteration. Dictionaries are incredibly useful for representing structured data like user profiles, settings, or API responses. Functions are reusable blocks of code that perform a specific task. You define a function using the def keyword, followed by a name, parentheses, and a colon. Any parameters, the inputs the function accepts, go inside the parentheses. The return statement sends a value back to whoever called the function. To use the function, you call it by name and pass in arguments. You can also set default parameter values. In our power function, the exponent defaults to 2, so calling power of 3 gives you 9. But if you pass a second argument, it overrides the default. Functions are fundamental to writing clean, organized, reusable code. Lambda functions are small, anonymous, one-line functions. Instead of writing a full def block, you use the lambda keyword, followed by parameters, a colon, and the expression to return. They are useful for short operations you only need once. Python also comes with many powerful built-in functions. Max and min find the largest and smallest values in a list. Sum adds all numbers together. Sorted returns a new sorted list. And map applies a function to every item in a list. Here we use a lambda to double every number. These built-in functions save you from writing lots of repetitive code. The input function lets your program ask the user for information. You pass a prompt string as an argument. This is the question displayed to the user. The function waits for them to type something and press enter, then returns what they typed as a string. This is important. Input always returns a string, even if the user types a number. So if you need to do maths with it, you must convert it. Use int to convert to an integer, or float for decimal numbers. Here we ask for an age, convert it to an integer, then use an if statement to check if the user is old enough to vote. Errors are inevitable in programming. Users type unexpected things, files go missing, networks fail. Without error handling, your program simply crashes. Python's try except block lets you handle errors gracefully. Code inside the try block runs normally. If an error occurs, Python jumps to the matching except block instead of crashing. You can have multiple except blocks for different types of errors. Value error occurs when you try to convert something that isn't a valid number. Zero division error occurs when you divide by 0. The finally block always runs, whether an error occurred or not, useful for cleanup tasks like closing files or database connections. Reading and writing files is something almost every real Python program needs to do. The open function opens a file, you pass the file name and a mode. W means write mode, which creates the file if it doesn't exist, or overwrites it if it does. R means read mode. The with statement is the recommended way to work with files. It automatically closes the file when you are done, even if an error occurs. File.write saves text to the file. File.read returns the entire file contents as a string. You can also loop through a file line by line, which is memory efficient for large files. Strip removes the new line character at the end of each line. Object-oriented programming is a way of organizing code around objects, things that have properties and behaviors. A class is like a blueprint for creating objects. The double underscore init method is the constructor. It runs automatically when you create a new object, setting up its initial properties. Self refers to the specific objects being created or used. Methods are functions that belong to a class. To create an object, you call the class like a function, passing in the arguments your constructor expects. Here dog1 is a Labrador named Rex, and dog2 is a poodle named Bella. Each has its own separate data, but shares the same bark and info methods defined in the class. One of Python's greatest strengths is its enormous library ecosystem. Python comes with a standard library of built-in modules you can import right away. The random module lets you generate random numbers and make random choices from lists. Datetime gives you everything you need to work with dates, times, and durations. OS lets you interact with the file system, create folders, list files, check if paths exist. JSON lets you read and write JSON data, which is the format most web APIs use. Beyond the standard library, you can install third-party packages using pip, Python's package manager. Requests makes calling web APIs as simple as one line of code. Pandas is the go-to library for data analysis. And Flask lets you build web applications with just a few lines of Python. Let's put everything together and build a real working quiz application. We store our questions and answers as a list of dictionaries. Each dictionary has a Q key for the question and an A key for the correct answer. We loop through each question, use input to ask the user for their answer, and convert it to lowercase so the comparison is not case sensitive. If the answer matches, we print correct and add 1 to the score. Otherwise we print wrong and show the correct answer. After all questions, we display the final score. This small project uses variables, lists, dictionaries, loops, if statements, functions, and user input, almost everything we covered in this course. You have just completed a full Python beginner course in 10 minutes. But this is only the beginning. The most important thing now is to practice every single day. Even 20 minutes of coding consistently will transform your skills faster than anything else. If you want to build websites, dive into Flask or Django. For data analysis, learn Pandas, NumPy, and Matplotlib. These 3 libraries are the foundation of data science. For artificial intelligence and machine learning, scikit-learn and TensorFlow are your next destinations. Or use Python to automate tasks in your own life, rename files, send emails, scrape websites. Most importantly, build real projects. A portfolio of things you have actually created is worth far more than any certificate. Join communities like r/learnpython and the Python Discord to get help and stay motivated. You've got this. Let's recap everything you have learned today. You now know what Python is and how to install it. You can work with variables, strings, numbers, and booleans. You understand how to control the flow of your programs with if statements and loops. You can store collections of data in lists and dictionaries. You know how to write reusable functions and use Lambda expressions. You can handle user input, catch errors gracefully, and read and write files. You have been introduced to classes and object-oriented programming. And you have explored Python's powerful library ecosystem and built a complete quiz app from scratch. That is an incredible amount of ground covered. Subscribe to Learn with AI for more AI-generated courses, and keep coding every single day. See you in the next course.